Okay, so welcome everybody.
We've made it this far. Yeah.
We've made it this far. Yep, I think this is week 6. So we're chugging along. Just a quick heads up. Hopefully we won't have any issues, but I've been having some problems with my laptop, and it's like when it opens up a certain amount, eventually the screen goes blank, and then I can't see anything, and then I have to close it down and reopen it, and that kind of thing. Hopefully everything will be stable and not not causing any problems. Just gives me a little bit of kind of like carpal tunnel or something, the strange posture I have to be as I'm typing. So anyway, I'm not lurking. I'm just in a new situation here. Yeah, so let's see. Today we're gonna be covering stuff for expanding the projects out from what we were doing this last week. So right, let's see. This last week we were placing things in or getting things to move and getting things to be able to respond to keyboard input. So we could have movement that was generated both in a what we might call a procedural way, which would be just allowing the animation to the targets to be able to move on their own. And usually we're doing that with just incrementing, right? So we had like a target.x that got updated every time that the game loop function was called. And that would either just move off the screen, or eventually if you got that far, maybe it would move and then hit some boundary point and then start coming back, that kind of thing. We can look at that a little bit more. So that's what I call procedural motion, because it's being moved by the computer with some sort of minimal rules that we generate. And that can be about speed, it can be about changing direction, all that kind of good stuff. And then the other type of motion that we dealt with was taking input, so interactivity from a user. So we are reading keyboard input, and then we're going to apply that to motion of, primarily we're working on with the main character, the hero character, right? So hopefully that stuff's all feels a little bit familiar, at least in terms of topics that we've covered. And then the other big thing that we covered last week, which may have been more of a headache for some than we would have hoped, is dealing with the FTP stuff, so the file transfer protocol. And some of that is just a headache just because you got to get used to that system. But sometimes it sounds like there are a few people also had some hiccups with the process, so that maybe their accounts were set up a little funky from IT and stuff like that. So if you're having any continued problems with
Did anyone get it to
FTP,
work?
yeah, I guess that's a good question.
Yeah. Did anyone get it to work okay? Or did we have all of those weird errors, those 403 errors?
I contacted IT, but I haven't looked into the solution they have provided yet since I got it yesterday. Sort of around
What did they say? Do you know?
I didn't look too carefully at it. Again, I'm going to look at it more today, but I think it was something to do with having to put a .index.html.
Yeah. Okay,
stuff.
good. And so I don't know. I sent that to a couple other people. I had seen that on the SOUIT website, and I didn't know about that. So I was wondering if everyone had trouble or if anyone didn't have trouble. We did set it up.
I didn't realize that there was a problem. I think mine went through fine, but I could also have just totally not realized that there was something awful going on.
Okay. Yeah, we'll be checking them. We'll check them out and see what's working. I mean, if you're able to get it to, you get your web address and type it in to Chrome, and you're able to access the file, then it works. So
yeah, that worked for me. So
awesome. Yeah, and I think one thing that maybe Mason was mentioning as far as the IT solution is there's a difference of if you are looking at something where you're trying to access a folder versus you're trying to access an HTML file, and that can sometimes throw errors. Where if you are trying to get if you're trying to access directly to an HTML file, like you did your project 1_2.html, and your address that you're going to goes into all the different folders that it's stored in and ends with the name of that file, hopefully you won't have any issues. But if you're trying to go into the parent folder that's there, it's often not going to let you get in there unless there is, as Mason was mentioning, a HTML file called index.html. And that means when you go in there to that's kind of a parent folder, it will automatically look for something called index, and it will load whatever's there. Otherwise, it doesn't know how to display a folder unless it is set up in such a way that it gives you permissions to see the contents of the folder, which SOU's server, I think by default, doesn't let you go in and see the contents of that folder. So yeah, let us know. Yeah, if you got if any of those solutions work, great. If you're still having issues, just stay in touch, and we'll try and get it fixed up for you and make sure that process is a little smoother.
They used to have a default index.html, I thought, on those pages, but maybe they don't.
On which pages?
On web pages.sou.edu. I think it used to have that set up just automatically, I think. But
so you could access folders?
Yeah, well, yeah, just so that the it seems like the it seems like the problem is that there's not an index.html, right? Is that right? Or is it in the actual directory that you're putting it in?
Well, let me go into mine. I'll start sharing screen here.
Yeah.
And we can look at my version here in CyberDuck. So here we are. So this is it looks like I was starting a connection here. And remember, we're always doing SFTP and then webpages.sou.edu. Your username is just the username, so not your email, just the username and your login. And then making sure that this line up here, I was noticing with someone we were trying to debug, that the URL really should say something like this, SFTP, and then your username at webpages.su.edu. And if it's not, that's probably an indication that something's funky along the way. Then we say connect, and should reconnect me. Okay, and then remember, everything you want to work with is within your public HTML folder. And if you so I just double click now, everything that's in here, even though I have a lot more stuff, is going to be accessible from the web somehow. So let me look at a couple of versions here and just see how I've done it. Okay, so for example, I have this Petri game that I've shown before. And you'll notice that the way that I coded this one is I created of my main code is this index.html. And so I put that in there. If I were to open this, you'd see all the code that you're, like the type of stuff that you're putting in your project, 1 point whatever's, that's all in this index.html. I've just named it index.html. And the reason I've done that is that then that allows me to access the website via this address. So if I go in webpages.sou to my username, and then I type in Petri and put a slash, if I hit enter, this should let me in. It might, from history, it might take a little minute to load. But here I'm providing it with a folder address. And it's letting me do it because it's coming here somehow. It's letting me do that because in my CyberDuck on the SFTP, I have this index.html file. So it knows when it sees the folder, it goes in and looks for it. Well, is there an HTML file I'm supposed to load to display? And by default, I'll look for an index one. And yeah, it found it. So compare that to, let me see another one here. What's more on TV? I don't even remember what that's. Probably a, well, let's see what more on TV is. Yeah. Oh, actually, I think I remember. This was a Travis's project from 2 or 3 years ago. So there's this folder, more on TV. We'll see in here, look at that, mtv.html. So it's not, it is not index.html. So if I were to go in and try and get this one instead, so I'm going to say more on TV, and I'm going to hit enter. It says forbidden. Okay, So it's not a not found one, but it's forbidden because it's not allowing me to display the folder. If it's instead, it would be looking for an index.html. So if I wanted to display this one, I have to go into the folder, which was more on TV, and then it was mtv.html, and no promises that this one's going to load because this was a student project from about 5 years ago that I stored on mine for a demo or something. Yep, and it looks like it's actually trying to load and it's trying to work. So I'm not getting that same error. So eventually it could work, and for nostalgia's sake, it might be interesting to see, but I'm not gonna waste our time doing that. Okay, so that's sort of I think one of the issues that can come up, but that doesn't really solve the 403 issue I think that people were getting, which might have been different. And Miles, you're muted.
Can you guys hear me at all?
Yes.
Cool. I was definitely having issues with that error as well the other night. But what you mentioned with the index, I just did that where I did like my project folder and then just renamed the actual project with the index, and it solved it completely. Okay. So I think if people haven't done that already, definitely try that.
Okay, cool. Great. Nice. Yeah, because then you just have to, you do whatever your address is and then just terminate it at the project that you're working on. That or include the name of the code that you're working on. So yeah, try those two options.
Yeah, it's weird because mine, I'm wondering if it has to do with the main directory having an index.html that lets people into that stuff at all. I mean, that was my suspicion that there might be something going on with that. But
yeah, well, I mean, and so there is definitely, not that we're going to get into it. There's definitely a lot of stuff that goes on behind the scenes. Yeah. In a way, we're looking in and saying, oh, this seems like we're behind the scenes and seeing everything that's going on, but we're really not. There's another whole level, like Miles was just talking about that with Sam and the classes that he was working on, but where you're having to really dial down into really what is the computer actually seeing. And at some level, there is, when you're dealing with servers, there is all these different permissions that get set up. And right now, all the permissions stuff is completely, we're completely blind to it. We don't see where permissions are set when we're doing this SFTP stuff, which means basically like who has access to be able to read, write, or download, or do anything with these files. And those permissions can all be set very particularly. So it could be that someone's user account has all files set default to non-access. No one can access it. And somehow you have to get those changed. So anyway. Yeah. So yeah, let us know, keep in touch, and we'll keep trying to debug on that. In the meantime, Miles put up for the assignment for this that was due yesterday, as well as we'll do that for this next week in case as well. Just allow you to be able to turn in the files as a zip archive. So if you're still hitting roadblocks in terms of getting things SFTP'd, just go to your folder. Let's say my Petri folder was the folder that had everything. Make sure it has everything you need in there, just like it's working on your computer, and then compress that and then upload that to the Moodle assignment. So if you can't send the link, at least send us that, and then we can always open it and check it out that way. Nice. Okay, so let's we will continue to debug that, but I want to start moving into some of the code stuff that we're going to be covering this week, which is going to be moving forward and starting to look at some, well, I guess basically starting to get a little bit elements of code to start working a little bit more dynamically for us. So rather than hard coding a whole bunch of stuff, which we've been doing so far, and it's been fine when we handle a couple things at a time, start working into more of an automation where we're able to tell the computer, hey, make me 100 game characters that are going to have all these different properties that get decided by the game itself, rather than us having to copy and paste 100 times to do that kind of thing. As well as then being able to manage things like the position of all those 100 things moving around and update it frame by frame, rather than doing that, telling, okay, let's target 1, move this bit, target 2, move this bit. We're going to make that happen all in a sort of dynamic way. And that's really powerful once we can see how that's working. And it's going to be bringing back some of our old friends from the CodePen days of dealing with arrays and dealing with for loops primarily are the 2 main things that we're going to be doing a lot with. So what we'll be looking at is over on the Moodle page, we're going to be working with this week 6, add targets via function, for loop, and array. So if you want to, you're welcome to go ahead and download that and look along there. I'm also going to be, and then I'll be demoing that stuff here. What I've done is, let's see, is this the right version? Yep. So there's the version that you have is already going to have more stuff than the version I'm starting with here. I want to sort of build things up from the ground up, but eventually we'll arrive at something very similar to what you see on your end. And a lot of the work that you have to do this week, a lot of it is really just sort of looking through, understanding, reading, getting a sense of how it works, and playing with what's there. So it's going to be a lot of the coding. You might end up just be uncommenting things, getting it to work, seeing how it works, see what happens when you change the variables, change the materials going in, all that kind of stuff. So while we'll be covering a lot of different pretty deep concepts in a way, you're not going to have to build up all those from scratch. Though if you're feeling comfortable, great, take these ideas and see if you can start applying them to other elements that you might want to develop in your games. So the first thing that I really want to start looking at is going down into our main loop. So let's just say that we've created, well, actually, I take that back. The first thing I want to do is a process of starting to make some targets. Okay, so we've in this situation, we've already made a hero, we've made a background, but we didn't make any targets yet in this version. And previously we'd made targets by making target 1, do all that stuff, make target 2, do all that stuff, make 3, etc. So instead, what I want to do is create a function that's called make targets. And then we want to be able to pass it a variable, which is going to be how many targets do we want to pass it. And if we see up here, this number of targets is a variable that hopefully we've defined globally somewhere, which we did up here. Right now we're saying 25. That seems reasonable. It's certainly more than you'd want to hand code in, and it's not so many that we know it's going to just totally bog down the computer, anything like that. So that sounds like a good starting point. So really what this means is we're calling a function called make targets, and then this number of targets is currently equal to 25. So we're saying passing the number 25 to that function. So let's go down and start making that function happen. So where are we? Down here is a make targets function. And if you downloaded the 1.3 version, you'll see there's a bunch of stuff in here, but like I said, I want to just sort of take it all out here as a starting point. So we have a function here. It says make targets and then how many targets. So when it's called, whatever value is passed then becomes this local variable that we're able to make sense of and use. So if we're dealing with a whole bunch of things, how do we want to store all their information? How do we want to control them? And if we look back, all the things that we did in CodePen, the thing that we used mostly when we had like a list of things, like multiple things, was working with arrays, right? So we had arrays that were able to store a series of numbers. It could store a series of words as strings, or we had mentioned it could store a series of objects. So these targets are more complex objects. They have an image associated with it, but then they have all sorts of other properties, its position, We can tell it its speed, we could tell it its hair color, we could tell it anything we want as a part of that. And all that can be stored in as one element of our array. So in order to make targets, I think we're going to want to have access to an array that we're going to be able to step through. And so let's just make sure if we do have an array set up for us. And in this case, we should up here. And in our global variables, we have this thing called targets array. And so it's just been declared as an empty array at the moment. But by using the square brackets open and close, that's a way of saying this variable is now an array. It's set up to hold a series of elements. And remember, arrays are counted from 0. So 0, 1, 2, 3, all of those, and each of the things in the array is called an element. So the first element as it is at index 0. Great, so we'll be able to add things into that array. So now back to move targets, or to make targets. So we want to be able to do things with a target array. And how many times are we going to want to do that? Well, let's just do it first here. We're going to say targets array. And we're going to, if we wanted to create one of them, we could say targets array 0 equals new create JS dot. This is just the info of how to make an image, right? Dot bitmap. And then images slash target 01.png. Okay, so there we go. That is the basic thing, right, that we need to do of creating an image. And then what else would we need in there? We might want to do the registration on that. We might want to do some other things. But before I get too far, I want to start thinking about how can I make this applicable for more than one? So let's think about that. We want to do the same thing many, many times. And the code that we used to do something many, many times, so we're going to want to do this 25 times, was, remember, a for loop. So we say, for a certain conditions, keep doing the same code over and over again until you're done. So reviewing on for loops, so we say for, and then we put in the condition that's it needs to meet, and then the code block that's going to happen associated with that. So the conditions we're going to say are going to be for the variable I is 0, so starting at 0. We want to go as long as I is less than our total number of things, which is here, how many targets we're going to create, right? So we're going to take that and we can say, so long as I is less than how many targets, then we're going to increment it I++. So this will work starting at 0, 1, 2, 3, 4, 5, 6, 7, 21, 22, 23, 24. Each of those times it will do this. When it gets to 25, this statement is no longer true. And so it does not execute the code on the last time, and it breaks out and then continues on with the other code. So that's the basic idea of a for loop. And so the other thing that we used, if you remember when we used for loops often, is using this I, which is just a temporary variable that's the counter of the for loop. And we would use that in the code block to be able to do things. So instead of saying targets array 0, if we say targets array I, we know that each iteration through the for loop, it's going to update that I, so it's going to be related to the counter. So if I just did this, this will create all 25 elements of our targets array to be holding a bitmap image of this target 01. So cool, that's great. That's basically what we need. So there's some other things that we need when we're creating each of these targets. So let's say, so the basic things we'll need are going to be well, let's do the reg, because we like that, targets, array. And here you get in this habit of talking to the element of the array. So whichever element of the array we're looking at, it's going to have, because it's now an image, it's going to have all the properties that images have. So we'll have a regex. So remember, which is the anchor point on the horizontal line, or like the horizontal axis, and a reg y, which is going to be like the anchor point on the vertical. So I'm going to set these just in ways that make sense for the for this image, reg y. We'll want to have a position. Targets array, I should just copy that because I'm going to be doing targets array a bunch. So let me copy. And so we have an X position, and we'll have a Y position. So you use all these .x and .y to go in to the current element of the array and look at the properties associated with that are its X and Y position. So this looks kind of funky because it's not talking to an image or a specific target that we would have set up with a separate variable, but it's really doing the same thing. It's going in and accessing one element of the array and then finding these various properties. So let's do some, I'm just going to copy and paste from what you have there, if you're using your versions of the same code, which it'll be save time. So this is going to then put in a random position for each of these that is dealing with so a random number based on fitting it in within the stage width and the stage height. And actually, I think this should be this one should be stage height, shouldn't it? I'm not going to talk through that in laborious detail, but we've looked at some of those things previously, and we can go back to it, revisit it. But it's going to choose a position within our stage between the minimum, which is 0, offset by a margin a little bit, and the maximum offset or inset by a little margin. Okay, so then the other things that we want, so let's just leave it at this now, is we need to have we need to add it to the stage. So that's something that also needs to happen here. So we add things to the stage by mystage.addChild. And what are we going to add to the stage? We're going to add the element of the array, targets array I. Okay, so if we just do this much, now I've coded a fair amount here. I want to sort of test and see that this at least is happening. So I want to save this. And I want to check, is my make targets function called? I believe it was up here. Yep, okay, good. And is my game loop happening so that it updates regularly? Yep, it is. Great, let's load this up and see if it works for us. So I'm going to pull this into Chrome. Okay, nice. So I'll zoom out a little bit so we can see the full screen here of it. And I have now my one hero, which has built-in movement going on using the arrow keys or WASD, and then 25 targets. And if I refresh, it should be targets in different places because they're all randomized. So that is a key thing right there. So we have now generated 25 things by using this function that encapsulates all that that info in there. And the real power, is that you can then put any number of complexities that you associate with each of these targets into that make targets function, so that when it's created, it has all that behavior, it has all that niceties to it, and it just gets stored in that array. So the storing in the array part is really just because it's adding it in as an element of the array, and then controlling its properties. So all the properties that we've worked with so far are ones that are built-in properties to the create.js, or create.js image, or bitmap image. But we can put in whatever else things we want as well. So we can put in speeds. We can put in, other things. What else is there we might do? Speed stuff. Yeah, let's just do speed now. So let's say target array I dot speed, and just to cut to the chase a little bit, we're going to do this for an x speed and a y speed. So why would we want to do that? Well, the main reason is because from experience, knowing that if we want things to be able to move around and eventually bounce off walls, you need to know if something hits a wall. To change directions, we often use the speed property as a way of changing the directions. I think we introduced that last week. So we had the idea that if the object is moving at a speed of 5 pixels per frame, every time the game loop function gets called, it moves 5 pixels one direction. If we want to set a boundary and say, okay, it just hit something, it hit the wall, for example, what we often want to do is then just tell it to change the speed direction or change the speed value. So instead of moving 5 in the positive direction, now we subtract 5. So it starts moving the other direction. And we'll find that if we want things to be able to move in up and down as well as left or right, we need to be able to flop those differently, because you might hit this wall, but you haven't hit the top. So you're still going to be going up. And when you bounce back, it's like Pong kind of thing. It's going to bounce off the wall, but it's still going to be going up, but it's just going to go left instead of right, or vice versa. So anyway, we want to separate speed X and speed Y. So I'm just going to come over and copy this stuff. Miles, did you want to add in something there? It sounded like you were about ready to fill something in there.
Nope. I was just having a moment, but
okay, nice.
No, we're good.
Cool. So what I have copied in is the version that you will see down there on 1.3, which is speed X and speed Y, which are random values that are being created by calling this other function. So there's a function that if we scroll down below, we'll find this roll range function. And this should look very similar to what we had created sort of at the end of CodePen days. We were asking you to create a function that would generate a random number between a range. And that's a version of that that's happening here. It might not be the exact same version of what you had before, but it's another option.
Yeah, and this is what I think this goes back to. I remember Katie asked the question a couple of weeks ago about, like, why do we do it this way? And so here we have an example of using a function that we made. We kind of labeled it a utility function here. So we wrote a function because we know we have to get random numbers within a range that will do that for us, so we don't have to keep writing out that code over and over and over again.
Yeah, nice. So here we get this target speed. We get a speed set up for our X and a speed for our Y. And I'm trying to see if there's anything else that we absolutely need in there. Let's leave it at this for a second, and let's get them moving, so then we can play with some of these other parameters. And then we might want to see some other options as well that we can add in, and seeing how doing a lot of work in this one little area, it's like it's creating a prototype, really, is what it's doing. There's an idea of like creating, here's what a target could look like. It could have all these different possibilities. And then when you call the function to make a target, it chooses which options and whatnot. It's what configurations and makes the target. So we can add some more into it in a minute, but let's leave it at this for the moment. And now let's think about if we want to start moving all of these targets. So to do so, we're going to want to have a function that's going to be, let's call it move targets, which we did here. I'm going to uncomment it from my game loop. So every time the game loop is called, 60 times a second, whatever it is, it's going to go in and run this move targets thing. So it's basically going to update the position of all the targets based on where they last were, and then what their speeds are, and any other conditions that we might have. So let's come down here to the right below this is a move targets function. And a lot of the same stuff we're going to find that we're going to be using. So I'm just going to copy and paste because I don't like retyping things. And we'll go in, and we're not going to need this, but that for loop, that is going to be the same as what we want. So we're going to, oh, no, it isn't. Sorry. I lied. It's almost what we want. So what we're going to want to do is we're going to, because move targets doesn't necessarily know how many targets there are. We're not saying move all 25 targets. We're just saying move all targets, move targets. So we need to know how many there are. And since we pushed all of our targets into an array, there's that wonderful property array.length, right? So if we say targets array.length, that is going to give us the total number of targets in there. So this will be return 25 currently. So it'll be able to work exactly as we want it now. And so now for each element in the array, we're going to update its position. And to do so, we will say targets array I. So whatever the current target is in this for loop, we're going to increment its x position. So a plus equals whatever its speed was. Targets array I dot speed x, because here we had separated those out. And same thing on the y. Great. And now let's save that, and we'll take a look and see what's happening. So I'll create these things, and there's no boundaries at the moment. Okay, so they all moved. Interestingly, what do you notice about their movement? They're all moving down and to the right, right? Different speeds and different angles, but none of them are moving up and none of them are moving to the left. So, okay, that's just something to note. Not that it's wrong or anything, but let's see why that's happening, just so we know, because you might want them to start, some of them moving this way, some moving that way, some moving that way. So the only thing that we've defined about the targets is their position, which was random, that was fine, but their speeds look to be all like they're all going to be positive values. So there's a minimum speed and a maximum speed, and it's going to return a value between those, but all those are going to be positives. They're going to be greater than 0 numbers. So let's see, looks like that's what, okay, yep. So there's a version in here in your example where we're calling like a coin toss or something. So some of these will make them be negative values, some of them. Let's say var coin toss x. So basically deciding, we're going to flip a coin, so to speak, and decide, should this one be negative, or should the x value be negative, or should it stay positive? So let's see. So coin value x, and we're just going to say math.random. The most simple version of math.random is just going to give us a random number between 0 and 1, a floating point, so a decimal number between 0 and 1, when that's called. And then if we were to, we can use a conditional and say if coin toss x is So in some cases, we want it to change, and some cases not. So let's say if it's greater than 0.5, then we'll change its direction, because half of the time, probabilistically, half of the time that will be the case. So if coin toss is greater than 0.5, then we will say targets array I dot speed x equals negative that. Okay, so let me save that and see if that worked. I haven't done it on the y dimension yet, but let's just see if that works. So come back here. So error, what did I do? Good, I haven't had any errors yet, so it's good to have some errors. So this is going into my JavaScript console and taking a peek in here. What does it say? It says unexpected token colon on line 121. What did I do? 121. That should have been a semicolon instead of a colon. Okay, let's try that. Save it, refresh. Okay, great, progress. So now it looks like some are moving to the left, some are moving to the right as they all come out. Okay, cool. So I'm just going to copy and paste, same thing on the Y. Coin toss Y, speed Y, speed Y. Save and refresh. Now, theoretically, error. Cannot read property X of undefined in 147. What did I do? Oh, I know what happened there.
What have you done?
I didn't do it. It wasn't me. Someone else. It's probably Miles's fault. No. What happened is I believe that the hero got created outside of the stage, or something like that. So I bet if I just refresh. Oh no! What's the problem? No. Is there any other place that it's happening? Just game loop 87, 147. So let's take a look. 87 in the hero boundary check, and then 147. Okay, how did I do something that made that now cause a problem? Well, the easiest thing is we can just comment that out because we don't really need the boundary check yet because we haven't talked about it. But what is being, so it's saying something in here is not defined.
It's saying that your hero.x is undefined. So
yeah.
It might be that your hero hasn't been added to the room. That's a possibility. Or your hero just hasn't been created.
Yeah. So let's see, because I didn't think I did anything that should have changed that. But let's take a quick look. So we get our hero
just
is.
Take out the call.
Just take out what?
Take out the call to hero boundary check.
Yeah, that should get rid of it. But I'm just curious why hero. So hero's here. Init game. Ta-da. Hero is added in here. Hero is added to the stage. And then yeah, interesting.
I have a question.
Yeah, go ahead.
How does changing the text in the target stuff affect your hero?
That's why I was kind of confused as well while I'm trying to track that down here.
So weird and evil.
So
it's not necessarily uncommon for stuff like this to crop up and just like having no idea what happened where.
Yeah, it's in definitely in the range of those disconcerting errors. Errors that there are errors that make you think, oh, okay, yeah, I understand. I didn't do that right. And then there's errors that make you think, what? What's happening? So that's sort of where I'm at with this one at the moment.
So what was the last thing that you added, David?
The last thing that I added was the coin toss here.
Okay.
And the very last thing I did was this line of the. Oh, okay. Well, I see I see what's happening. I don't know why we got that error, because it's checking here on line 122 for this coin toss Y that I haven't created yet. So probably if I fix this, it will fix the problem, but it doesn't explain why why it was giving me that error. So let me test it. Okay, so it solved the problem. I do not know why, so I'm not going to tell you why. I would have thought that the error should have been line 123, coin toss Y undefined, or something like that. But anyway, it threw me that other error.
That kind of reminds me of, I think sometimes you'll get an error that says like init is undefined or something like that, where we're like, geez, if we've done one thing, we've defined init. So why is that a problem? And this kind of reminded me of that same thing where it's like, well, we know we already set that up. It was already working. Or like Katie said, like, why is that a problem? And a lot of times it's because like, and then Rad said, well, it's not that uncommon, because if you screw something else up that leads into that section, it's like a cascading problem or something.
I think in this instance, it might be that because coin toss Y was the last thing referenced, but it wasn't attached. Notice that the boundary check. Never mind. Okay, I don't know this one.
Is the boundary check the next thing that would be done?
I was just thinking that the boundary check might be the next thing down, but it doesn't look like it is.
Yeah. Well, anyway, let's we'll leave that to the CS majors, and just realize that we figured the problem out, or we got a solution for it. Okay, so back over here, we got this happening, refreshing, and they're all flying away now in all directions, which is nice. So we got movement, we've generated targets. One thing that we might want to put in here, and you'll see this example happening in your in the example code. So I want to sort of describe what it is that there might be situations when you want to have more dynamic choices happening when you're generating a target, rather than them all being the same image. For example, you might want to have different types of targets that appear. And you can do all that same sort of thing in here. You could, of course, have a separate function that's like make this type of target, or make round targets, make square targets, make coin targets, whatever. All those could be separate functions that you call, but you could also build that into a single function like this. So right now, the key thing that's differentiating things would be the image. What image are you going to be using? So if we want to, we can say something that ends up making a choice between a few different targets. And you'll see that in the code that you have as an option that's currently commented out. But we could say something like this. I'll do a version var, and actually by doing so, I'm going to use a thing that I don't think we've talked about. I mentioned it in one of my sections, which is called a switch case, to be able to do this. So I'm going to say which target. So we have 3 different target images that we can use, and I'm going to create a random number that's going to be a rounded down, so it's an integer of a random number between 0 and 3. Okay, and so this is the funky nomenclature to do that. We make a random number between 0 and 1. We multiply it by 3, and then we round it down to the next lowest integer. So, and that's just stored here in this thing here. So there is a wonderful thing if you're going to be testing multiple cases of something, like a number against multiple different options. You can do this with if-then, which is actually what we have, like if-then-else, which is what we have in the example code. But there sometimes can be a more efficient way of doing that, or sort of a clean way using a switch case. So let's just look at it real quick, what it looks like. And so this is one I always forget the specific syntax of. So I just say JS switch, and then I go to my W3 schools, and wow, the web is going really slow on here. Hopefully the video seems to be going fine. It's like, I guess Zoom is just taking over all my bandwidth. So this is the basic idea. We switch some, and there's some variable that we're going to be testing. And in certain cases, you do this code, and other cases you do this code, etc. And then if you have matched a case and it matched a condition, then you say break, and you sort of like don't check any other cases, move on with your life. So let's do that right here. So I'm going to say switch, and I'm going to be switching which target. And then what else did it say? Short-term memory leak. There we go. Okay. So put it in curly braces, and then we say case, and we have different cases, which in our cases are going to be integers. So it's going to be 0, 1, or 2. So in the case of 0, we can say do something, and then something we're going to do is this code. And then we say break, and then we say case 1. We do a similar thing. So it's in the case that, it's sort of like how I read it, in the case that which target is equal to 2, do this code. And then I'm going to switch these so that they're not all the same. Target 1, 2, 3. Save. I'm going to, again, confirm. Looks good, looks good. Yep. And you can have this default thing at the bottom, but you don't have to. Default means like, if it doesn't match any of those other cases, do this thing. But ours should be fine. So let's try that. So I'm going to comment out this one that assigned them all to be target 1, and then see if we can do it this way instead. Save. And go over here to our code, refresh. Hey, it worked. Awesome. So let's see that again. Multiple different things flying around. So the nice thing about that switch case is that it's basically a series of if-then statements, but it gets a bit more compact. So if you ended up having 10 cases, you wanted to have, if you had 10 different targets that it could be, then it's just a lot cleaner, easier to read than a series of ifs and else ifs. Nice. So that gets us a variety of things going on there, all generated here within this make targets, and then we update the position with the move targets. So the only other thing that we really want to put in here right now is that we do want to deal with boundaries. So we haven't really talked about that yet. There's some boundaries already in this code set up. So let's see them in action here. And they are associated with the hero. And you can see what's happening is that when you get to one end, it disappears and then shows up on the other end. So it sort of like wraps around from top to bottom and from left to right. So whichever direction it's doing, it does that wrap around, which is one way of doing things. It could also be a hard wall that you can't get beyond. It's just sort of your call, your design based in there. So let's look at it. This is hero boundary check, the thing that we thought was giving us a problem. And what it's doing is some if-thens here, checking if the hero is greater than, so it's if the X is off stage right by some amount, make its position off, like just invert it so it becomes then the just off screen the other side. Sorry, that was an awkward way of saying that. But that's what's happening in here, and that happens in the X and the Y dimensions. So makes some sense. They're doing some sort of niceties in here using the reg X, which is like that half, it's the midpoint of the character. So once the midpoint of it gets over there, it sort of shifts it back over to the midpoint on the other side. You could also do that some different ways if you wanted to completely go off the stage before coming on the other way, or setting up however you want it to look. So, but let's do the boundary check for the objects, for the targets now. And we're going to do that a little different way though. So let's do them so that they're going to bounce, so that when it hits a wall, it changes direction. Okay, so to start with, I'm going to go and copy from my move targets, because we know that every time you check the boundaries, you're going to need to check it on each individual target. So that means you're going to iterate through the array. You're going to see all 25 that are in the array, or if you put 1,000 in there, whatever it is, however many, you're going to go through the array to do it. So I'm going to start with this. Okay, so now we have our for loop that goes in for each element of our array. Inside of that, we're going to need to do a conditional. We're going to need to check, so is it greater than some point, that kind of thing. So if target, targets array I, so our current one that we're looking at, if its X is greater than stage width, so it's too far off to the right, minus, I'm going to put in that the reg thing as well, minus targets array dot I dot reg X, which means it's going to just get to that line and then hopefully change directions. So in that case, we're going to say change its direction. Targets array I dot speed X is going to be equal to, or is going to get the negative speed. Great. So let's just test that, and then we'll start adding more to it. So I'm going to refresh. Oops. Token on 160. 160. If those are let's see. Unexpected token 160. So what did I do wrong here? We got our if statement, we got our for loop, we got our function. 160, if targets array I dot X is greater than stage width minus targets array, dot I. Okay, it should have just been targets array I had extra dot in there. Okay, so now let's check it. Oh, nothing's happening and I know why. Let's see if we actually call this function. And the answer is no, we did not. So we got to check, we got to tell it that we want to call that function. So I'm uncommenting it up here from my game loop. Save it. Now go back. Refresh. Okay. So something's happening. They're bouncing off when they hit this wall. The other walls they disappear on. Bounce, bounce. A couple of them that make it. Great. So let's extend this now to those other walls. So we do that down here. Target boundary check. So we could do a couple of different ways. We can add in some more if statements, which is great. So I'm going to do that here. Well, I'll do it in a second. You can add another if statement, or we could do is use an or as a part of our if. So I'm going to show that one. So or is these two straight lines. It might take a little while to figure out where they are on your keyboard, but if you do two straight lines, that means or. So if this condition or whatever the condition after that is true, then it will do the code that's in here. So the other condition that I want to test is, so if it's all the way off to the right or all the way off to the left, both of those conditions you want to change the x position. So here I'm going to say, or the x is less than, basically less than 0 plus that registration amount. So I can just get rid of the 0 and say if it's less than the registration amount. Great. So let's see what that is. Refresh. Bounces on the right, bounces on the left, not on the top or bottom. Cool, that's as expected. Boing, boing, boing. So now I just copy that whole thing that's happening on the x, which is this, and I can duplicate it for the y, because I have a top bound and a bottom bound for my y. So I'll come and say y, 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 and y, and y, and y, y, and y, and y, y, and y, and y, because.
But why, David?
You don't know that? It's a Harry Belafonte song.
Oh, that's right.
Why and why and why? Why and why and why? Because. Good night, good night. Okay, yay!
Woohoo!
So they might be jittery on your side, but they're bouncing off of all the walls, and my character can still move around everywhere inside of here. Okay. Cool. So that is really like the core functionality that we're trying to get happening. Is the biggest one of them, I think, is the idea of making multiple objects through a function. So that was our make targets function, and trying to get in the habit of putting more and more of the code in there rather than other places. So like when an object is created, you try and give it as much identity as possible right then, because then you can always access those parameters later, do cool stuff with it. But it's sort of like you're generating this thing that's going to have all of its potential in there. And then that allows us to then access it later to do things like this: move it, check conditions, like when it gets to a boundary. And that's really an extension of the idea that we'll be looking at more next week, which is collision detection, which is when two objects so-called collide. You're going to have to be able to test that as a condition. Like, are these two objects overlapping? And if so, what are you going to do as a response to that? And that's really what we just did here with the walls, thinking that the walls are a minimal type of collision detection, which is like if your X is moved to a range where it more or less is touching where this boundary is, do something in response to that. And so if you want to look ahead and play with it, you can do that with there's a library called Collision Gnome that we'll start looking at. But yeah, go ahead, Miles.
Yeah, I was just thinking that that we're talking about now this week and next week are I think the two key things to starting to work with interactive art or games, because if you think about being a kid, when you're playing, I remember being a kid, I was obsessed with pinball. It was kind of before video games. And so my brother and I tried to make a pinball game. We kind of did, got a piece of laminate. My dad helped us out, and the ball would go out, it would bounce on stuff. But what was annoying is that you could never really do a score, because you could say, oh, if it hits this, it's 10, but that's kind of lame. You know what I mean? It's like the point of pinball was that it was automatic. It was electronically doing this for you. And then you couldn't tell if it hit it twice or if it hit it, it was, or if you played basketball as a kid and you're like, that's a foul. And they're like, no, it's not, so you're getting into these kind of arguments all the time. But that's what's kind of cool about working with the computer, is that we're talking about automating these things. So, and you can set up like your toys to be in a certain place, but they don't move on their own. And so what we learned today is how you can set something up and then have the computer move these things on its own for you. So it's like this automated process, which is pretty cool. And then so next week we're going to be talking about a collision. So you can see like, well, did it hit the thing or not? Or if it did, how many times did it hit it? Did an event happen or not? Did it actually happen? And so that's a really, really big part of this whole process. And collision detection can get pretty complicated, but we'll kind of start simple. And so we actually did some collision detection today with a boundary check. Did a target or did the hero hit the maximum or minimum point of the stage as a way of checking collision? So it's very cool. It's exciting.
Nice. Yeah, I'm trying to think of what other things there might be that we want to try and talk about today, or is that, or if we want to leave it at that.
I had one overview we could talk about, just about the code itself, just to kind of, because, when you look at all this stuff like we've been doing today, it gets kind of intimidating, and it's really, really easy to lose your place in where you are. So, and I think that we've noticed as we've been teaching this, that if you can kind of keep pulling yourself back to a point where you are the one that's asking the questions, you're the one that's kind of in charge, so to speak, of the way this is being developed. So if you can kind of own it, the more you can own it, which is hard to do when it's only the second or third time you've looked at this, but the more you can kind of think about it as you're the boss, not David or me, or that you're the one kind of constructing this, even though we're kind of giving you the framework for it. If you can kind of say, okay, what's actually happening and why? And if you can simplify it, keep simplifying it down to the point where you understand it. And then if you hit a point where you don't understand something, that's the time to ask questions, is at the point, but base it off of your understanding. And so if you find you're like totally lost, just keep dialing it back, keep going back to the point where you have the question. And then you can ask those questions. And then I think, Rad and Willow and Nick are great at answering these questions as well. Other people in the class can help answer these questions. And so the more we can kind of talk about it, the more you can it becomes organic, and it becomes more of this process where it's oh, this is me thinking about it. And so you're not necessarily trying to worry about the right way or the wrong way, but you're trying to get like, okay, this is what I think is supposed to happen. And that's what actually is important, is what you think is supposed to happen. So to that end, I just wanted to kind of go over, give us a little overview of the code. And I'm going to actually look at last week's, because it's a little simpler, but it still holds up for this week as well. So here, I'll go ahead and jump this. Looks like I need to enable, David, if you can enable the screen share, I'll grab that.
Thank you.
They might have changed that default, because I had that come up with me the other day too.
Let's see, where is it?
I think if you just go to screen share, there's an option there, advanced options or something. Yeah, I don't think it used to do this, but now it's automatically disabled or something.
Okay, got it.
Yo. Cool. So I just screen capped this over here. Whatever. All right. Cool. And let's take a look at it. So here's the code that we were working with last week. And excuse me. And so what I did is I collapsed all of the functions. So they're just, we're not looking at any of the detail inside of the functions. And this is really the key point, I think, to starting to understand the overview of what it is that you're actually doing. Because it's not clear. I mean, because we're learning about math.random and math.for, and we're learning about if this and then and for loops. There's so much detail in that, it's really easy to lose track of the overview. So when you first of all, just by collapsing these functions, you can start to say, oh, there's not that much stuff. And and more particularly, if we kind of break this down, we can see what the areas are of this code. So like we said, there's the HTML, which is everything in the angle brackets, and there's HTML down here. So that's good to know. We talked about the canvas object, and we talked about the call to the function init down here. And then in our JavaScript proper, we just have two sections. We have global variables, and then we have, these are all function definitions. So basically, you're doing two things, and those are the two things we worked on in the first 3 weeks of class, which is that you're either declaring variables or you're writing functions. That's a really simplified way to think about it, but like I said at the beginning, that's the whole point, is to simplify it. Because once we understand that simplification, we can do things, we know what that means. And until we understand that, it's really hard to do things. So we're going to declare variables and we're going to write functions. That's it. So that's the whole thing. So that's kind of nice to think about. It's like, oh, okay. So the next step, I think, in understanding this is to think, okay, well, what do these functions do? Because I think we understand variables, though if we don't, this is a great time to talk about it. But so variables, we say, var is that keyword. It says create a variable named my stage. That's it. Line 15 there, or line 16, create a variable named stage width. And those are not assigning a value to those variables yet. And then some of them do assign a value, like in 18, create a variable named my frame rate and assign it the value of 60. All right, so those are the variables. But let's think about the functions. And so the functions we've written in last week, we end up writing, what is that? 5 functions. And so what are those functions? And so let's look at the first 3. So init is going to be, it's called by the HTML down here. So this is what we're talking about, is a chain reaction. So we're setting off a logical chain reaction where it's like something calls something, which calls something else, which calls something else, which calls something else. So we create this chain. So the chain starts here with the body, because all this HTML happens automatically. The browser just does it. And then the last thing it does is it calls this init function, which is in our JavaScript. And what the init function does is it's going to set up the stage, the create.js stage object, and it's going to set up the create.js.ticker object. So it's going to set up those 2 objects. And that just happens once and never has to be dealt with again. The last thing init does is it's going to call init game. And init game sets up our hero, and it sets up the targets, and it sets up our background. And down the line, it could do things like, we set the score, that kind of stuff. So init game it's going to just set stuff up. set up the stuff that's going to actually show up on the screen. And then game loop is going to be called by the ticker that was set up in a init. And so ticker is going to run 60 times a second, and 60 times a second it calls the game loop. And the game loop is just going to handle our movement, and it's going to handle our checks against the keyboard. Is the key being held down or not? And then lastly, we have these last two functions we've written down here are the handlers, basically, you know, for the keyboard. So handle keyboard, what's it going to do? Handle keyboard checks with the conditional if key monkey, you know, W. It checks if a key is being held down, and if so, it changes it. It changes the hero's X or the hero's .Y, and eventually, I think this week we have a move function or something like that. It can call that function, or it can just directly say hero.x plus plus. And then the move target function changes the targets .x and .y properties automatically, just says do it. And because that's called by the game loop, both of these functions are called by the game loop. So the game loop is automatically calling these functions 60 times a second. So that's just what I wanted to kind of, acknowledge that we've gotten to this point. We're actually doing a lot of really complicated stuff. And it's a lot of new stuff, but there's a structure to it that you really want to, now's the time. Like, we're kind of halfway through this process, and you've covered a lot of stuff. So now is the time to really work on consolidating it in your mind so that you understand, oh, this is happening. And because that happened, it causes this to happen. And then because that happened, it causes this to happen. And so you want to understand that back and forth. You want to understand that backwards and forwards, sideways and right ways and all that. So really think about that. And you can use that little simple thing of just collapsing the function can really help clarify what's going on. That, oh, all this stuff is contained in these function brackets here. So anyway, that's it. I just wanted to kind of go over that overview.
Nice. Yeah, thanks. I think it's good to sort of be able to step back, and because that's going to be able to apply to any code you're working on. You know, it's not just this project, but any other future coding projects you might take on. And I think a big part of that is also just thinking of things as modules, like thinking modularly as much as possible, so that there would be ways in coding that you could code, for example, most all that we've done in, like, put everything into that game loop, and just that game loop does all this stuff in a very expanded version, but it would be very difficult to read and difficult to sort of understand what's happening when, etc. So an additional part of that is just making these things little modules that, okay, the game loop's going to go over and over and over again, and within that it just does these four things, and it calls this function, it calls this function, it calls this function, and this other function. So it sort of like sends out to the functions that do most of the actual work, but you're clarifying the structure in that process.
Yeah, and think about it as like teaching yourself. Because in a way, everyone is self-taught. I mean, David and I are up here, teaching, but in a way, it won't actually work until you've kind of taught yourself, until you're kind of breaking it down and trying to explain it to yourself. So you're testing your understanding. You're saying, like, okay, so this calls the init function. Where's the init function? It's here. What's in the init function? Like teach yourself that way. And then when you have a question, you're like, oh, why is this here? Or why is this here? Why couldn't it be here? And so then I think that's when you start to make progress. And that can hopefully, you can, bring those questions to the recitation or to the Discord and all that. So that's where it gets fun. I think that's where, because I think where I was frustrated with coding is where I didn't even know why something was wrong or why it wasn't working. And then when I started to have a question, it's like, okay, now why isn't this working? Because I think this should work. Then it started to change. I could learn. It was easier for me to learn at that point.
Cool. Great. Well, let's see if there are any questions or things that you want that we could address right now. Happy to do so. Otherwise, I think that's the main sort of content stuff we're really trying to get your way this week.
Yeah. So if you're oh, go ahead.
I was actually curious, just to expand on border and margins kind of things. If we wanted to create a safe zone for the hero that was like 20 pixels or 60 pixels around the background image, how would we change the coding to allow for targets to remain 20 pixels away from the safe zone if we were to create one?
Nice. Yeah, let's take a look and see if we can do that. Let me share over here. So there might be other ways. I'm sure there's other ways to do this. But I think the way that I'm thinking of looking at it would be, let's go into the boundary check and basically make an additional boundary check. Ooh, this one might be tricky. So I'm imagining that if we had like a little central square or something like that, that if it hit that, it would just bounce off of that, for example. Is that something kind of like what you're thinking of?
Yeah, something along those lines.
Yeah. So probably the easiest way would be wait till next week, in a sense. Using the library that we have, the collision gnome, you could make an object, even if it's an invisible object, that would be present in that space, and you could say you detect collision, and if that collision is made, then it would change directions. But we might be able to do it also in here. So the trick, I think, is going to be that so far when we've been doing test conditions, so let's say imagine this my fist is a ball, or the thing that we want to hit and change direction. So like the target's coming in and then it hits it and we want to change directions and go back out. But so far we've been testing things about greater than or less than. So we'd say if it's greater than some amount, if the X is greater than this point, we want to go back the other direction. But all this stuff over here, which is also free to move, is going to be greater than that. So it's a little more nuanced than that. So we might have to do conditions that are ands. But it looks like Miles maybe has a smarter path.
As you're talking about this, because this is spot on. This is, for me, this has been really key to doing this kind of work graphically. And this is where it's tricky, because I think in the first 3 weeks we weren't dealing with graphics. And so it's a little easier to think about things in the abstract. Excuse me. So can I share the screen just for a second?
Yeah.
And we can even talk about this for a moment, like, because I think what David was just explaining is spot on. Like, that's exactly what we have to do, but it's kind of tricky to actually understand what exactly that is. So let's see, let's share here. There we go. So I just, in Photoshop, I just kind of threw this together. So like, if this is your hero, and then you're kind of talking about having a safe area out here, right? So if the hero goes out here, they're safe. Is that what you're talking about, Katie?
Yep.
Yeah. So I think the first step is to actually, for me, is to visualize it, is to draw that out. And once I draw it out, then I know what I'm trying to get, because this is where I'm trying to translate my idea, the human idea, which is like we can all get this as we say, hey, so the hero's in here, and when he's in here, they can be hit by objects, but when they get out here, they're safe, they're okay, and they can't be hit. We're like, yeah, got it, right? That's kids playing tag. Like, this is the safe zone. And so, but that's actually complicated to describe to the computer is like, huh? So if the first step that we can do is maybe visualize it so that, oh, okay, safe, unsafe, safe, unsafe, safe, unsafe. And so then what David's talking about then is the next step.
Yeah. What I was talking about is being hard to explain things to me as well as the computer. So I was,
Right.
because I was envisioning more like an island in the middle that was a safe island. So
yeah.
So this one will be easier to do than the safe island in the middle. But
Cool.
maybe we can do both. So
yeah, and I think once you do one, you can do the other. But it's kind of like it's just more or less little scribbles. So the I don't have my pen hooked up, unfortunately, so I can't do the cool like drawing style. So I have to do it with the mouse. But like if you think about like, well, what do we know? So if we know the hero is like, we know the dimensions of the hero. So the hero, and we know the registration point of the hero. So if I just really quickly draw like, okay, so here we know the registration point is in the center. So that's the registration point is in the center. The reg X and the reg Y are centered so that and then we know that the kind of half, and this is going to get into what we're going to do next week, but half of the hero's width is going to be 32 or 64, so if it's 128 then it's 64. So we know, and then we can start to figure out what these conditions are out here, so that if the hero is here, the registration point is here, so which is there. So that's where the hero's actual X position is. So that's going to be 64. So that way we can start to determine where this is. And so anywhere where the hero is, and so then we have to determine, and this is where the game developer, this is where how you want to handle this, Katie, is like, is the hero safe? This is the boundary conditions we were talking about with is the ball inbounds or out of bounds? In soccer, the ball is inbounds. In basketball, the ball is out of bounds. So this is where you have to define and this is where human language, is it safe or not? So if this is in the safe zone here, and this is cool, that number it's no longer 64. So, but it's showing us what we should check for. So let me erase that. That part here. Whoopsie daisy. Oh my Lord. Yeah, so if we erase this, so this becomes like a question, like what is the hero's X position, is what that little green line is telling us. So if the hero is only safe if they're fully inside, that means it has to be at 64 or less. So anyway, that's just kind of showing you the idea of how this might work. Anyway, so.
Yeah. If we wanted to see, do we want to try and get it to happen?
Do it.
Okay. Let me share here. So I did something that I thought would make that happen, but maybe it hasn't yet. So what I'm looking at is our boundary check, because if we just had our boundary was our stage, but then we shrink it in so that then that where it's going to pivot is going to be slightly smaller, just like what Miles was showing in there, and slightly smaller by the right amount. So I'm basically going to be changing my conditionals in here. So these used to be stage width. So like our far right check was going to be if it hit the stage width minus the target's registration. And so I'm moving that back in further. So we have our stage width, which is the full farthest to the right. We want to move back by our hero is 128. Is that right, Miles?
I think so.
I think so. So we want to move back by 128. And the way I got that is by our hero's reg x and then times that by 2. So it's the midpoint times it by 2, should be 128. So if it's that way minus the width of the hero, or it is this way plus a hero, yeah, then we change direction. And then we would do the same on the y side, so which is what I have here. So let's see if that's working. Come here and refresh. It doesn't seem to be working, unless I'm zoomed out or something now.
What should be happening, David?
Well, what I'm wanting it to happen is when one of these characters, one of these targets, hits a wall, sort of an invisible wall, before it gets to the end, it will turn back its direction. Right now, it's still continuing and going all the way to the wall before it turns back. So let's see here.
The target should be bouncing off a tighter
box. Yeah, a smaller box. Yeah. Mm-hmm. So stage width minus, let me just do this with hard-coded numbers.
Yeah.
Minus 300. And if it's greater than 300, minus 300, greater than 300. And then we could make it relevant or related to some of our targets or something later, but let's see. Whoa, okay. So it's working for all these ones in the middle, but if they were generated on the boundary, they got the jitters. So some of them are being generated if they're being generated outside of that safe zone, or sorry, inside of that safe zone. No, outside of it. Whatever. Mm-hmm. In the safe zone.
Some of them are stuck in the limbo. The reason why some of them are stuck is that they're kind of going because they're kind of constantly held within these conditions. And so this is a great example of like Nick uses one of his favorite analogies is what NASA would call a limited success. And so that's where they would be testing rockets. And so if the rocket went up for a tenth of a second and then turned this way in the next tenth of a second and then turned down and then exploded and destroyed everything, they go, oh, well, it was a limited success. So, it was supposed to go up and go into orbit, but it didn't quite get there. But something did happen when we pushed the button. Limited success. So that's a good example. What we got there was a limited success. We're like, oh, well, actually, it's working. Mm-hmm. For these, so if you focus on that's cool. Something happened when we pushed the button, but now we've got to go in and refine the question. We've got to refine it.
And so I think here what happened is we fixed, another way of looking at it is I think we made a solution that works, but now it's pushed the problem to where the objects are generated.
Generated.
The objects can sometimes be generated outside of that zone, and which puts them in that weird jittery state because they're constantly, every frame, changing directions. So we would have to go back and look in here at where the X and Y is generated and constrain that to be within our new dimensions. And maybe here it's the stage margin. We could just change what the stage margin is going to be. And so stage margin is what? 128. So let's set that to be 300. And let's see here if that does it. Okay, so there you go. It might be a bit too much of a margin that we've created, but it gives you the mechanism of how that works. And it's really interesting how that then this visually changes or makes a very different experience from something where things are always coming up and around. Now it's almost like, seems like a little school of fish or something, and you're coming in and you could be a character that comes in and like, oh, I got to grab one and then get back out. So it's it's a very simple change in a way, but it creates a very different type of interaction and experience in the game.
Yeah. That's really cool. I think the other thing about it too that's funny is like it's an example we talked about with Pong. You're kind of getting something for free. Like, so if you look at if you go back and share the screen again, David, I think what's kind of brilliant about this is like you actually you've made a potentially a complicated problem really simple, right? So we don't actually, the thing I love about this is we wouldn't actually have to go and change our collision code or collision checks at all. We wouldn't have to say like, well, don't check if it's like, no, it just won't, the hero literally won't hit anything if it's outside, if it's just moved out, because the targets aren't there to be hit. So I love it. It's like really elegant, you know, it's like a really simple solution to that problem. So I think that's really cool.
Yeah, great. And just because we haven't done it yet, I want to make more targets.
Oh no.
Yeah, do it.
Let's
get crazy.
So, and it's interesting to me how things like this, when you get more and more of something, you actually can start seeing the mechanics a little bit in the other ways. So like I'm now, again, I'm sure it might be hiccupy on your end, but I start really seeing the box.
Yep.
Like this looks like a box, even though it's, you know, it's not always perfectly formed. It looks square. Whereas when it was back at 25, it almost looked more sort of circular. I'll go back to 25. It was like most of the time they're kind of in that thing and you're not really noticing the box character to it. So I don't know what to say about that other than it's sort of an interesting conflation of like a structure and then the individual behaviors in there.
Well, it's exciting. I think you're talking about like potentially like, you know, data visualization and information graphics and all that kind of thing about like how it gets to be really interesting as a way to think about like, oh, okay, what is what? Like, like, cause I think the visual app, like when we visually apprehend something, like if we just said, like if we just looked at the code and said, oh, number of targets equals, we wouldn't understand, that wouldn't mean anything to us. But when we see it visualized, we're like, oh yeah, okay.
Yeah.
I see what this is doing.
Yeah.
Yeah.
And this also points, you know, outside of gaming and other things. Well, I mean, you can use it in gaming as well. It's basically emergent behavior. You're sort of seeing a form that results from little decisions that are happening at the small scale, and you're seeing it resulting in some sort of larger scale form. You know, there's no box being drawn here, obviously. What there is in this case now 500 little things that are behaving according to a series of behavioral decisions. And, you know, like you can think of it like flocking of birds and stuff like that. This is a very, very simple version of that, but it's just one object that makes a decision. Oh, I hit this point, so I have to change my direction. And the result of that fairly simple reaction is something that becomes a fairly complex, larger environment or emergent environment.
Yeah, there's a lot of potential in there. That's really cool.
You mind showing the code again?
Yes. So the two things that we changed were in making targets. Here we had to create the, well, all I had to do was change the value of the stage margin so that then that was going to be, they're going to be built within that smaller space. And then the key thing was then in the target boundary check, I changed these values so that the boundaries were shifted in here just by a hard-coded number of 300. 300 pixels in from the right, 300 from the left, top and bottom.
And I'm assuming you can use the same code if you wanted to change the hero's boundaries as well.
Yeah, you could do a similar sort of thing to apply to this character. Yeah, to the under the hero boundary check. So
awesome.
think about yeah, of course. Yeah, so think about whenever it adds something or subtracts something to these stage widths, those would be the places to find that.
Yeah, and the idea I think is, Katie, if you can define what you want the hero to do. So if the hero is here, then this. So if hero is here, then this happens. And then the trick is then what's this? And how do we tell if the hero is in that condition or not? And what is this that happens once we determine that? Cool.
Great. Yeah. Any other questions or things we can help with?
Good time. All right, great. Well, we'll let you guys take off. We'll hang out and we can answer some questions if people have individual questions. That's fine. Otherwise, see you guys on Wednesday.
Sounds good.